All right, we're going to be talking about cereal plate dilutions and how to perform them, as well as do the calculations. The procedure is pretty basic. After we incubate the samples that have been diluted, we are looking for plates that contain between 30 and 300 colonies. Using the number of colonies, we can divide by the dilution tube the plate came from and the amount we plated. That is also a type of dilution. So we can determine the colony forming units per milliliter. This is a very important procedure to know how to do, so make sure you guys understand the math behind it. The basic procedure starts with our sample, which we will then dilute in some water. We will vortex around, get it evenly distributed. We will then take 100 microliters, which is the same thing as 0.1 mils, from the original sample and place it into a tube with DI water, about 900 microliters. This will make a 1 to 10 dilution, which we'll talk more about in a second. We will then repeat this process several more times. And then from one of these tubes, we will take a sample from the plate and grow the bacteria. And we will count up the number of colonies. And if it fits within the range that we need, we will then use that to determine our CFU per mil of the original sample. There are some important equations that you guys do need to know. The first one is for calculating dilution. It's a pretty simple one. It's the amount of sample divided by amount of sample plus diluent. The next one is 1 mil is the same thing as 1 gram, which is the same thing as 1 cubic centimeter. It's also considered cc, which you'll probably hear in a healthcare context more often, but cc just stands for cubic centimeter. Lastly, you should know what the CFU per mil calculation is. It's the number of colonies divided by the mils plated times the dilution. So if we take this first example, we have 0.1 mils of sample divided by 0.1 mil of sample plus our diluent, which is 9.9 mils of H2O. This is 0.1 divided by 10.0. However, this is a little awkward to do, so we want to move the decimal places over. So we move them over on top, we'll move them over on the bottom, and this becomes 1 over 100, which is the same thing as 10 to the negative 2. We'll call this our mix A. We'll take a sample from mix A, 1 mil, and put it into 9 mils of water. To do this equation, we do 1 mil of mix A divided by 1 mil of mix A plus 9 mils of H2O. This is 1 over 10, which is a 10 to the negative 1 dilution. When we do serial dilution, to determine the final dilution from the original sample, we have to multiply them together. When you multiply negative exponents together, you just add them together. So in this case, 10 to the negative 2 times 10 to the negative 1 is 10 to the negative 3 total dilution. It's important to remember this conversion setup. 1 over 10 is the same thing as 10 to the negative 1, which is also the same thing as 0.1, and this will become more important in just a second. Let's try a real-world example. Let's say we have a sample, and we're going to dilute it 1 mil into 9 mils of water. This is a 1 to 10 dilution. We'll call this our mix A, and we'll do it again. And that's a 1 to 10 dilution. And we'll do it one more time, and that's also a 1 to 10 dilution. These dilutions are all relative to one another. However, we typically only care about the total dilution from the original sample. So whichever mix we are taking from to plate colonies, we want to figure out what that dilution is from the original sample. When you multiply negative exponents together, you add them, the top number together. So as you can see, this one, mix A is just 10 to the negative 1 total dilution. Mix B is a 10 to the negative 2 total dilution. And finally, mix C is a 10 to the negative 3 total dilution. From these, let's plate 0.1 mils from each tube. For our mix A, we had too many colonies. It's over 300, so we can't count it. We list it as too numerous to count. For mix B, we had 158 colonies, which is within the 30 to 300 range. Finally, in mix C, we had 22 colonies, and while we can count that, the number is too low to be statistically viable, so we consider this a too few to count plate, and we no longer use it. In this case, we will only use the 158 colony mix B plate. We will then begin by doing the calculations for this. We have 158 colonies divided by the amount plated. In this case, it's 0.1 times 10 to the negative 2. Now, if you guys remember, 0.1 is also can be represented as 10 to the negative 1. So 10 to the negative 1 times 10 to the negative 2 is 10 to the negative 3. When you divide by negative exponents, you just put them up on top as positive. So this becomes 158 times 10 to the 3. Of course, we always do scientific notation while we're doing numbers. In this case, we'll move the decimal place over from the 158 over 2 spots. And yes, they do make that noise. You can do that in class. Please feel free to. And this becomes 1.58 times 10 to the 5th. Because we move the decimal place over 2 places, we then move it over to the power of 10. Whenever you do an answer, of course, you need to use units. In this case, it's CFU per mil. So make sure you guys always put the units. And whenever you do math problems, it makes it much easier if the final solution is boxed. That way it's very easy to identify what you are trying to accomplish. If you are confused about any of these topics, please let your TA know, or come see me as well after class, and we can work on this together. It is very important that you guys are able to calculate the CFU per mil. If you have any questions, make sure you guys let us know. Thank you.